Hi students, today we are going to discuss about potentiometer. So what is the use of potentiometer? It is used to measure potential difference. So potential difference is between 2 points. Already we have studied about voltmeter. So voltmeter is also used to measure potential difference. And when we have studied voltmeter, we had discussed that we will make the resistance of voltmeter very high so that we will be getting the maximum possible precision or accuracy. But compared to voltmeter, potentiometer works totally in a different way. We can see here it works on null point method. It doesn't withdraw any current from the original circuit. So we will discuss that in detail. It will not take any current from the original circuit. So how do we connect voltmeter? If some resistance is there, a part of a circuit, we will connect the two ends of voltmeter to that resistance. So whatever be the voltage across the resistance, this voltmeter will show. Or a group of resistance or a part of a circuit, big circuit, some part. We need to know the potential difference between 2 points. We will connect the voltmeter, take the reading bus. So but when we do so, some amount of current will pass through voltmeter also. So because of this small amount of current, accuracy will have to compromise. There will be a small difference in the real value. So potentiometer will avoid all those accuracy problems. Okay, this doesn't take current from the circuit, so it will give accurate reading. That is the advantage of potentiometer. But this is bulky. When we try to calculate the voltage or potential difference, the problem is we have some labor work here. Potentiometer, we just connect it, we just look at the instrument, it will show the reading, bus, over, matter is over, our duty is over. But here it is not so. You can see here, this is a scale. So we will have to do some measurement, we will have to take some measurement, we will have to do some manual calculation, but correct reading, that is the guarantee. But here we have some work. So it is not that easy to use potentiometer. So for all the general purpose, we will use voltmeter. If it is very precise calculation, if we need to take, we will be using potentiometer. That is the difference between them. Now just I will give small introduction about potentiometer. Then we will discuss its circuits and all. See, basically, all these are copper strips. Okay, all these are copper strips. So between these copper strips, suppose a 10-meter long wire. So if we keep a 10-meter long wire straight, the entire instrument will become 10-meter long. We cannot afford such space in our lab or whatever activity we are doing, wherever we are doing. We cannot afford 10-meter long instrument. So what we do, we will connect that 10-meter long wire into different pieces like this. So this 10 meter or 400 meter or 40 meter or 4 meter, whatever it may be, from one strip we will be connecting like this. So this entire length of wire will be within a box. That is what we have shown like this. This is the way it is connected. But when we try to calculate, we will make it appear like a straight line. But you should get an idea. So I have drawn like this. Okay. One end, this is called a driving battery. This is called a driving battery. This is connected to one end of the potentiometer wire. This is called a potentiometer wire. Potentiometer wire is nothing but a resistance wire. The other end is connected to a switch, then to rheostat. This rheostat resistance we can adjust, that is connected to the other end. the device or the part of circuit which we need to measure the voltage, that will be connected like this. Suppose here this is a device, its voltage is what we are going to measure. This could be a resistance also, this could be a battery also, whatever it may be. This is the external circuitry. Please understand it very clearly. This is an external circuitry. The voltage of this device we are going to measure. So one end will be connected to A, another end will be connected to a jockey. Here I need to add one more thing. This will have a galvanometer also. A galvanometer. So this jockey, this wire connected to jockey, this we can move through this wire. We can move through this wire. We can move through this wire. Wherever it is stopping, this galvanometer deflection stops. Ig is equal to 0. When this doesn't show the deflection, that is when no current is passing through galvanometer, we will measure that length. That is how this works. Okay, this is a small introduction. We shall discuss everything in detail. One difference I am going to make in the circuit, instead of this 4 lines and all, we will connect this potentiometer wire as a single wire. Okay, then we will further explain so that it is easy to understand. Clear? Now, what are the uses of potentiometer? I said we can measure the potential difference between 2 points or any circuit. In addition to that, there are few other uses also. Basically, use is one. Okay, but it can extend to some other uses also. One is to determine the EMF of a cell. If we get a battery or if we get a cell, we do not know what is its EMF. We can find it using potentiometer. So obviously, if we can find EMF of a cell, we can compare the EMF of 2 cells. Then to measure the potential difference of any circuit, any part of the circuit, okay, I can say it is correctly like any part of the circuit. Any part of the circuit. Then to determine internal resistance of a cell. If we get a cell, we do not know its internal resistance, we can find internal resistance using potentiometer. Okay, so the methodology or the concept to find all these are same. Okay, small extensions will be there, small extra circuitry will come, so we can solve this. Then I can say that these 4 uses are 4 different types of problems we get. Okay, in potentiometer, I said all these 4 uses, these are the 4 different varieties of problem we get from potentiometer. If we understand the concept and simply if we apply the concept, we will get the answer. But usually considered as very confusing, difficult topic, potentiometer is. So these are its uses. These many varieties of problems can come from this topic. Clear? Now we will see the principle of potentiometer. Okay, the principle of working of potentiometer. So it is based on the principle that if constant current is passed through a wire of uniform cross section, the potential difference across any segment of the wire is proportional to its length. Suppose if there is a wire and its cross-sectional area is uniform, cross-section area of throughout this wire, that must be uniform, and we are passing a constant current through this. We are passing a constant current through this. Now the voltage across any segment is proportional to its length. Okay, say for example, suppose if this is a point, this is another point, if this is A, this is B, then we can say that the voltage across the points A and B is proportional to its length. That is, this, if this length is L, okay, this is proportional to its length. Suppose if we take a small part from this and if we name this as X and Y, and if this length is LXY, then the voltage will be proportional to what? LXY. If we increase this, that is, if we just simply, the idea is, if we measure across AB, the voltage will be more, or if we measure the voltage across X and Y, the voltage will be less. In short, if we pass a constant current through a wire of uniform cross-sectional area, then the voltage is proportional to its length. Okay, if we measure to a more length, if we consider 2 points, okay, which is very distant, voltage will be more. If we reduce the length, voltage will be less. Again, if we consider another 2 points of lesser length, voltage will be less. Okay, so we can say that this comes from the resistance formula also. Okay, resistance R is equal to rho L by A. Resistance R is equal to rho L by A, and we know the voltage difference or potential difference is nothing but IR. So we can write that I rho L by A voltage. So if we take different lengths, if we take different lengths, say for example, if I take these 2 points, okay, suppose if this is 1 meter, okay, then this is a voltage of 1 meter. Suppose if we take these 2 points, and if this length is 10 meter, then this is voltage of 10 meter. Then I am saying that voltage of 10 meter will be greater than voltage across 1 meter. If this is same line, same area of cross section, same current is passing through this. This is the principle of potentiometer, we can say. Note it down. Idea is very simple. Constant current, constant area of cross section, voltage is directly proportional to length. That is the simple idea. Same current, same area of cross section. Okay, if length is small, or if we consider a smaller length, smaller voltage. If we consider more length, more voltage. Simple concept. Now suppose if we consider 1 meter length of wire, or we will constant current uniform area. Okay, this is the condition. Okay, this condition, it must be there. Okay, suppose say for example, if we have taken 1 meter length, when we measured, we got 10 volt. We took 2 meter length of the same wire, same current is passing, we got 20 volt. We take 3 meter, we got 30 volts. So as the length increases, what is happening? The voltage across, the potential difference across the terminal is also increasing. Suppose if we take a wire, we marked 2 points A, B. Current I is passing through this. This is the length of A and B. Okay, now here voltage, we can write that voltage is proportional to this length L. If we change this point to this, to another point which is lesser, this voltage also will come down. Again, if we make it closer, this length will decrease, so that voltage also will come down. Now that is, voltage is proportional to length of the wire. Now when we write proportional, something is proportional to other quantity, then what we used to write, in order to equate it, we will be equating it with a constant. V is equal to K into L. So this K, okay, this K is called voltage gradient. Voltage gradient. What is voltage gradient? Simple. K is equal to V by L. Unit is volt per meter. Okay. The potential difference per unit length. Potential difference per unit length. This is what is called the voltage gradient. Okay. Okay, this is what is called voltage gradient. Okay. Per meter, how much is the voltage? Per centimeter, how much is the voltage? Okay. So suppose if we know that per meter, okay, voltage drop or potential difference is 2 meter per 2 volt per meter. Okay, 2 volt per meter. In a meter, if we consider 1 meter, there will be 2 volt potential difference will be there. Okay, so 2 volt per meter in a single length. Like if we consider 1 meter, okay, in that 1 meter 2 voltage drop will be there. So 1 meter 2 volt per meter is the voltage gradient. 1 meter 2 volt per meter is the voltage gradient. Then for 2 meter it is going to be 2 volt per meter into 2. For 10 meter 2 volt per meter into 10. Likewise we can calculate. Okay, so take this. Voltage gradient is nothing but voltage drop per unit length. Suppose if we consider a length, okay, so if this is 1 meter, in 1 meter we have 2 volt drop. That is, I am saying that the potential gradient is nothing but 2 volt per meter. Example, okay, in 1 meter 2 volt drop will be there. Suppose if throughout the length of the wire 10 volt is there, if say for example this is 10 meter wire, in 10 meter wire throughout 20 voltage is there, then first 1 meter 2 volt drop will happen, next 1 meter 2 volt drop will happen, likewise at the end entire thing would have dropped there. Okay, so we will see like this. Now K is equal to 2 volt per meter. At 1 meter, okay, 2 volt drop is there. Now same wire, if we consider 2 meter, so for 2 meter how much will be there? 4 volt drop will be there. Okay, likewise we can take, or simply we can say that for 1 meter K voltage drop will be there. K is the potential gradient. So for 1 meter K will be there. So for 2 meter 2K drop will be there. Suppose if we take from here, if I consider 3 meter, so for 3 meters, say for example 6 voltage drop is there, means it is nothing but 3K drop will be there. 3K drop voltage gradient. So same way if we consider X meter, then it is nothing but Kx or Xk voltage drop will be there. Clear or what? Okay, so simple concept is simple. I repeat, voltage drop potential difference is directly proportional to length. So that is nothing but V is equal to K into L. V is proportional to L. V is equal to K into L. What is K? K is nothing but potential gradient. What is potential gradient? How much voltage drop is there per unit length, or K is nothing but volt V by L. Okay, total voltage divided by total length. That is a voltage gradient. So voltage gradient is nothing but the potential difference per unit length. That is for 1 unit. So for 2 unit, 2 into K. For 3 unit, 3 into K. For X unit, X into K. That is the main crux of this potentiometer. Hope you understood. Okay, I repeat again, V is proportional to L length. Voltage difference is proportional to length. Now voltage gradient is nothing but K, total voltage divided by length. So for 1 meter voltage drop is K, for 2 meter 2K, for X meter XK. Okay, so how much length is there? That much into the voltage gradient is the total voltage across that length. So for X meter, XK volt will be there. So this is nothing but 2 volt. So K into 1, here 1 into K volt, 2 into K volt, 3 into K volt, X into K volt. This is unit. Okay, clear? Now using this concept we will develop, we will learn the concept of potentiometer. And this K is scalar. Okay, K is scalar, potential gradient. This is scalar. Take this simple question. This is just to understand how to apply this potential gradient concept. Okay, find VAC. VAC means voltage across the terminals A and C. So across this terminal, what is the voltage? This is the question. Find VAC if the voltage across the terminal AB is V. Okay, so voltage across AB is equal to V. So this much is given. Find the voltage across AC. So now voltage across AC is nothing but, if we know the voltage gradient, we do not know the voltage gradient. Now we are trying to understand voltage gradient. So we will be using voltage gradient method here. So VAC is nothing but this length. So voltage across this length is nothing but the voltage gradient of this wire into its length. Okay, voltage across any 2 point is nothing but voltage gradient of that wire into that length. Bas, nothing else. Now what is voltage gradient here? Voltage gradient K is nothing but the total voltage across the length divided by its total length. So voltage gradient is nothing but the voltage across this AB is nothing but V, and the total length is L. So this is the volt per meter. Okay, the voltage drop across unit length is this much. So what we can do? V by L into X. So this is the voltage across the length AC. Clear? Okay, so this is Kx or V by L into X. So voltage across any 2 points is nothing but voltage gradient of that wire into its length. Okay, clear? Now we'll see the construction and working of potentiometer. The original setup, that is the wire that is made into several segments and made it into a portable set, that we have seen. Now in order to get a proper understanding and for easy explanation, I have made that this kind of potentiometer wire setup I have converted into this form. Okay, fine. Now see, potentiometer wire consists of AB, this setup only, AB, of uniform cross section, generally 4 to 10 meters long, fixed on a wooden board. It will be fixed on a wooden board. Clear? Now what we do is we have a driving cell. From this cell current will generate when we switch on rheostat. So generally what will happen, this is not connected now, current will start flowing like this. Initially current will be flowing like this. Now we need to measure the potential difference of a device. Okay, so we need to find the potential difference of this device. This can be a resistance or this could be a battery, likewise. So now what we do is when we connect this, we connect one end to A, the other end of the device we will be connecting to a jockey through galvanometer. Now this jockey we will be touching to this end and we will start moving. So galvanometer will be showing some deflection. So we just connected at point 1. We are gliding through this. Okay, we will be gliding through this wire from this end to this end like this. Suppose at a point 1 galvanometer was showing some deflection. Now when we tried this jockey at point 2, galvanometer was showing deflection in the opposite direction. What I am saying is there could be galvanometer deflection other direction or this direction if at the two ends. What we are trying to do is we need a point where galvanometer shows zero deflection, that is no current. So gliding through this, finally we got the galvanometer connection at this point. Say this could be, this is C. Okay, a point C we have found. So at point C there is when we connected this jockey at point C, no deflection in the galvanometer, that is no current is passing through this. Okay, now suppose if this end we name as D and this end if we name as F, then when this galvanometer shows zero deflection, when there is no current passing through this part. So no current will be passing through this, otherwise current will be passing through this, current will be passing through this also. So galvanometer was showing zero deflection. So when this jockey, when we moved, we got a point where we will be getting a point where whatever be the potential here at F, the same potential will be there at point C. Galvanometer will show zero deflection when there is no current. When there will be no current, current will not be there when 2 points are at the same potential. Current flows from higher potential to lower potential. So we will be finding this length. Suppose the total length of the potentiometer wire, if the total length of this potentiometer wire, if this is L and if this length which we have found is X, the resistance of this potentiometer wire is R. So we can say that simply potential at A will be equal to potential at D because no current. Potential at C will be equal to potential at F. Or simply we can say that potential across AC, that is the potential across the terminals A and C, will be equal to potential across the terminal D and F. Okay, so no current between this circuit says that this potential must be equal to this potential. Clear? That is the working. Note it down. Now, what is the voltage across the points A and C? VAC is what? With respect to the potential gradient, we have discussed about potential gradient. Potential gradient is voltage per unit length, voltage drop per unit length, or voltage difference per unit length. So voltage across any length is nothing but the potential gradient into that length. Voltage across any length is potential gradient of that wire into that length. So voltage across AC is nothing but the potential gradient of this wire under a constant current into that length X. Okay, so this is the potential across AC. This is the potential across AC. So that same will be the potential across what? This device. So this will be same as potential of the device. Okay, or potential across the device. Just remember this, things will be easy. Okay, if you understand this concept, we can apply the same concept in all the problems of potentiometer. Now, the first type of problems or first type of application which we need to discuss is determining EMF of a cell. Okay, now in the place of this device, what we are getting is EMF of a cell. So we will replace this device with a EMF. Okay, so a cell and an internal resistance R, and this is the EMF of the cell, and remaining all the setups are same. Now we do not know what is the length. Okay, we will connect this galvanometer. We will start from this end. This scale is there. Using the scale we can measure this length. So just as usual, we will start from here and we can go up to this. So while moving this, at one point galvanometer will show 0 deflection. So there we will stop. Okay, there we will stop. So galvanometer shows 0 deflection, Ig will be 0. Now we have studied about terminal potential difference. We have studied it in detail about cell. When there is no current passing through the cell, what will be the voltage across the cell? When no current passes through the cell, what is that voltage across the terminals of the cell? Or we can say when no current passes through the cell, no current is coming out of the cell, what is the terminal potential difference? EMF itself. Okay, when we have studied this before, but I am reminding, when no current is flowing from cell, then terminal potential difference is nothing but EMF, which is nothing but the voltage or the potential difference between between two terminals of a cell. Okay, the potential difference between two terminals of the cell. Now what happens is, no current passes through this, no current is passing through this. So between this D terminal and F terminal, I can say that the voltage difference across D and F is nothing but EMF of the cell. EMF of the cell. Okay, so this is one point. Another point is what is the voltage across AC between A and C? If this one we have measured as X, what is the voltage across A and C? Nothing but simply the potential gradient into X. Potential gradient into X. So these two are same. This voltage and this voltage are same. That is the reason no current is flowing. So simply we can say that, okay, we can say that the EMF of the cell will be equal to Kx. How to find K? V by L. Which V by L? Voltage across this potentiometer divided by its full length. Okay, voltage per unit length. So take the voltage, measure the voltage across the full potentiometer wire. No current is passing through this. Current will be passing only through this. Very simple. V by R equivalent is the current. So that current into this resistance is nothing but the voltage across this wire. Okay, see. So EMF is nothing but Kx. Now, what is the current passing through this? the current, suppose current is passing through this, okay, current is passing, I is coming, I is coming, I is coming, I is coming, I is flowing like this, no current here. So what is that I? That I is equal to no EMF here. This EMF cannot pass current here because these are same potential. This E0 divided by how many resistance are there? This resistance R plus this resistance, rheostat resistance is there. If this cell has any internal resistance, that also we can add. Okay, so this is I. And what about V? Which V? The voltage across AB. VAB is nothing but I into R. I into R. So from this we can find K. K is nothing but VAB divided by L. So just like a normal circuit, we will be able to solve the problem if we understand the concept. Now another point is conditions for getting null point. So can we say that in all the conditions, okay, even if we move the jockey also, Ig will be 0. Okay, there are some conditions for getting that. What first condition is E0 must be greater than E, that is this driving cell, that battery must be, its capacity or its EMF must be greater than the cell which is trying to check its EMF. Suppose if this EMF is greater than this one, then we won't be getting null point because definitely this will be sending some current. Okay, so when that null point will happen, when the voltage difference between the points must be same. So if this cell is of higher capacity, then that won't be possible because even if we move full, still this cell is of high capacity, definitely current, it will be delivering some current, some amount of current. So first point is this. Another point is E0 positive must be connected to positive of E, or E0 negative must be connected to negative of E. This cell and this cell, they must be in opposite polarity. If they are in same polarity, that is negative minus plus minus plus, if it is like that, then definitely both will be aiding current in one direction. Definitely we won't be getting null point. If they are plus minus, still to one side it will be aiding current. So they must be connected with the opposite polarity. These two conditions are must in order to get null point. If these conditions are not met, we won't be getting null point. Okay, important points. So if they want to make the question very tough, okay, they can make them same polarity. One option can be there, that is there won't be any null point. We will be trying to find out using this method, and all, suppose even if we get any answer wrongly also, that will be there in the options also. So note down these conditions. Now I have just mentioned how to determine K, that is voltage gradient. Now we will see once again in detail how to determine K. Driving cell, rheostat resistance, and this is potentiometer wire. So A, B, this is potentiometer wire, its resistance is R ohm. Now we are connecting SL of EMF E, galvanometer, jockey. So here suppose a current is coming from the driving cell, I is coming from this cell. Now once if we get galvanometer deflection is not there, Ig is equal to 0, we know that current I will be going like this. Okay, now we moved the jockey and finally we got the galvanometer current as 0. Okay, now we need to find the potential gradient K. So what is potential gradient of this wire? Voltage per unit length. So V divide by L. Suppose if this length of this wire is L, then K is equal to V by L. What is V? That is VAB. Okay, VAB. Total potential across this wire divided by its length is what? Voltage per unit length. Voltage per unit length. Potential drop per unit length. Potential difference per unit length. All are same. Now what is VAB? Voltage across this. Suppose if this is a resistance, if this is R, if I is going through this, voltage across this R is nothing but IR. So same way this is going to be I into what is R? Small r. Okay. Now what is this current I? I is equal to what? This EMF divided by equivalent resistance E naught divided by R equivalent. So what is R equivalent? How many resistances are there? Rheostat resistance is there, this wire resistance is there. So rheostat resistance, okay, plus small r. So I is going to be E naught divided by rheostat resistance plus this small r. So VAB is equal to I into R, means E naught by rheostat resistance plus R into small r. Okay, so K is nothing but this whole thing divided by L. So likewise we need not by heart this. So just like how we usually solve a circuit, same way just find the current into R divided by L, will be getting voltage gradient. Okay, clear? Okay, so voltage gradient we can say simply K is equal to I into R divided by L. Okay. So now we will do some problems. A potentiometer wire is 10 meter long and a potential difference of 6 volt is maintained between its ends. Now find the EMF of a cell which balances against a length of 180 centimeter of the potentiometer wire. So suppose if this is the potentiometer wire, just say we will put a name AB, and now driving cells and are all there, but we need not take it now. Okay, see here, simply a cell is connected, okay, and a galvanometer, and somehow jockey found a point where galvanometer shows 0 deflection. That is what they say, that balancing against. So this is the balancing length. So balancing length is 180 centimeter, say AC. Total length of the wire is nothing but 10 meter also. Okay, so this is how the question is. So find the EMF of the cell. What is the EMF of the cell? So what is the EMF of the cell? So suppose this potential, that is nothing but EMF of the cell. No current is flowing, no current. Ig is equal to 0. So this potential, that is this EMF, will be equal to this potential. What is this potential? VAC will be equal to what? Kx, potential gradient into that length. So finally what we can get? EMF is nothing but VAC is equal to what? Kx. So EMF, to find EMF, what we can do? Kx. So what is Kx? What is K? X is how much? X is equal to 180 centimeter, it is given. What is K? K is nothing but VAB divided by its length, potential per unit length. So how much is VAB? 6 volt given. Potential difference of 6 volt is maintained across its ends. 6 volt divided by length is given as 10. So we will substitute there. So E is equal to 6 by 10 into 180 centimeter. Okay, 180 centimeter. So into 10 raised to minus 2. Okay, so this can be cancelled off. 6 into 18 into 10 raised to minus 2, we will be getting 1.08 as the answer. 1.08 volt as the answer. Clear? So very simple. Okay. Whatever be the voltage we need to find. We need to find the voltage here. Actually EMF. So this will be equal to Kx, voltage gradient into that length. Bus. Just apply that concept, you will get the answer. Take the next question. A 10-meter long wire of uniform cross section with 20 ohm resistance is used as a potentiometer wire. This wire is connected in series with a battery of 5 volt along with an external resistance of 480 ohm. Okay. Now, if an unknown EMF E is balanced at 600 centimeter of the wire, calculate the potential gradient of the wire and the value of unknown EMF. So this potentiometer wire, okay, its length is how much? 10 meter, and its resistance is given as 20 ohm. Then a battery which is nothing but driving cell only. Okay, unknown EMF is other one. This is driving cell, and this resistance, rheostat resistance, also given as 480 ohm. This much is given. Now an unknown EMF is connected. Okay, unknown EMF is connected, and which got its balancing length at 600 centimeters. So this length is 600 centimeter. Now first thing is which we need to find potential gradient. So potential gradient K is nothing but, if this is A, B, now directly the potential difference of the wire is not given in the question. Now you will find it. Okay, so potential gradient K is equal to VAB divided by length L. Length is there. VAB, what is the potential difference in the AB wire, that we do not know. So VAB is nothing but the current that is passing through this into its resistance R. So what about I? This current IG is anyway 0. So the current that is passing through this I, how much is this? This is nothing but E divided by this resistance plus this resistance. Only that much is there. No other resistances. Okay, if internal resistance of this is given, that also we will have to add, just like a normal circuit. So E is given as 5 and R is given as 480. Potentiometer resistance is given as 20. So this is nothing but 5 divided by 500, or we can say 1 by 100. This is the current. Now what is VAB? VAB is I into R, 1 by 100 into 20 ohm. So this is VAB. Now K is nothing but VAB divided by L. So 1 by 100 into 20 divided by 10. Length is 10. So this we can cancel. So if we cancel this is going to be 1 by 50. So 1 by 5 is 0.2, 1 by 50 is 0.02. So either this one or this one is the answer. Okay, I mean option. We need to find the EMF also. Okay, clear? So now once if we get the potential gradient, finding the unknown EMF is easy. Finding the unknown EMF is easy. Unknown EMF is nothing but Kx. This EMF is equal to this one, the potential difference of this one, Kx. So this is K we got as 1 by 50, and this is 600 centimeters. So 600 into 10 raised to minus 2. So this is 0.02 into 6 actually. This we can cancel out. So this is going to be how much? 0.12. So option C is the answer. Clear? So potential gradient is the potential drop per unit length. That is nothing but the potential difference across the wire AB divided by its length. Now how to find the voltage across that wire? Current into its resistance. So how to find that current? The driving cell EMF divided by R equivalent. Okay, it's just like a normal circuit. Once if you understand the concept, this is easy. Clear? Understood? So potentiometer, basics, construction, working, and just one type of problem, how to find the EMF, okay, of an unknown cell. Only that much we have covered. Now we need to explore more. Okay, one more session on potentiometer in order to compare the EMF of two cells, to find internal resistance. All these things we will do in the next session. Okay students, thank you, goodbye, good luck.